Imagine a city built in one of the hottest deserts in the world, with waterfront properties capable of housing approximately 250,000 residents. A city built not by reclaiming land from the sea, but by carving canals deep into the sand and bringing the ocean inland, extending the shoreline by 200 kilometers. That's not science fiction. That's the Sabah Al-Ahmad Sea City, Kuwait's $5 billion megaproject that is doubling the country's coastline. You're watching Megaconstructs, where we explore colossal builds from around the globe. Let's start today's journey. In one of the hottest deserts on Earth, Kuwait is building something that sounds like it belongs in a work of science fiction. A city carved directly into the salt flats, designed to bring the sea miles inland and transform a lifeless landscape into a thriving waterfront community. Kuwait's economy is built on oil. With 101.5 billion barrels of proven crude reserves, the country accounts for roughly 6% to 7% of the world's total oil. But Kuwait knows that oil won't last forever. That's why the country is working to diversify its economy. And one of the most impressive megaprojects in the Middle East is the result. This is the story of Sabah Al-Ahmad Sea City, a $5 billion gamble, a triumph of engineering, and a city that is literally reshaping the desert. The vision: turning desert into sea. Sea City is located in the Al-Quran area of southern Kuwait, about 85 kilometers south of Kuwait City and not far from the Saudi border. What makes this project unique is the method of construction. Across the Gulf region, developers have typically built artificial islands by dumping sand into the sea. Think of Dubai's Palm Jumeirah. Sea City does the opposite. Instead of reclaiming land from the sea, engineers have carved a massive network of canals directly into the desert and then flooded them with seawater. The idea wasn't new. Kuwaiti engineers first proposed expanding the natural tidal channels in the area back in 1989. But then, just 1 year later, the invasion of Kuwait by Iraq forced the entire plan to be shelved. It wasn't until after the Gulf War that the project was revived. Buro Happold, a UK-based engineering firm, won an international competition to design the city, and work began in earnest in 1998. The first phase of the project was opened to the sea in 2004, and the city was officially inaugurated in mid-2016. The numbers: a city of unprecedented scale. The scale of the ambition is exceptional. The project aims to create approximately 200 kilometers of new coastline, effectively doubling Kuwait's natural beachfront. The development spans 6,400 hectares, 64 square kilometers, an area roughly the size of Manhattan. The master plan, which has a projected construction timeline of 46 years divided into 10 phases, is designed to accommodate up to 250,000 residents when fully completed. It will deliver over 11,000 residential units and plots, with the vast majority featuring direct beachfront or waterfront access. More than 3,000 contractors from 20 countries have worked on the project, often around the clock. To give you a sense of the scale of the earthworks involved, over 250 million cubic meters of material had to be excavated, graded, and reused. That's enough to fill the Great Pyramid of Giza over 60 times. The engineering challenge: building on sand. But how do you build a city on desert sand? The ground in the Al-Quran region is made of sabka, a fragile mixture of loose sand, fine mud, and weakly bonded salt crystals. When subjected to heavy loads, the soil particles continue to rearrange themselves, causing prolonged settlement. In other words, any heavy machinery entering the site would immediately risk sinking into the mud. To deal with this, engineers had to transform the weak ground into a buildable foundation. They installed a network of pumping stations to lower the groundwater level, creating a dry and more stable working surface. Then, they deployed a technique called dynamic soil compaction. Here's how it works. Massive steel plates weighing 25 tons are welded together to form pounders. These pounders are hoisted by 6-bower MC96 duty cycle cranes and dropped from a height of nearly 12 meters onto the ground. Each impact location is compacted roughly 15 times in succession. The kinetic energy from the impact forces trap groundwater and air out of the soil, allowing the sand and silt particles to reorganize into a denser and more stable structure. The process is fully automated, with operators inputting target parameters like compaction levels and impact counts into the crane's intelligent control system. The cranes then execute the process automatically, moving systematically across a predefined grid. This process densified the soil to an effective depth of approximately 5 to 8 meters. eliminating the risk of long-term settlement and bringing the ground's load-bearing capacity up to the required infrastructure design standards. The water, a self-flushing lagoon system. Once the ground was stable, the next challenge was the water. The site originally contained 2 natural hypersaline creeks and extensive salt marsh that supported almost no marine life. To create a healthy, tidal waterway system without relying on energy-intensive pumping, engineers needed to use the Gulf's limited 2-meter tidal range to drive natural flushing throughout an intricate network of channels. The solution was a system of tidal flapgates installed at the connection points between the lagoon system and the open sea. Each gate weighs around 10 tons and operates entirely in response to natural tidal movements. When the tide rises, the gates open automatically, allowing seawater to flow deep into the inland canal network. When the tide falls, they close, helping maintain stable water exchange pressure throughout the system. As a result, more than 27 million litres of seawater per minute pass through these tidal gates, providing enough hydraulic force to refresh the entire lagoon system without requiring continuous operation of industrial pumping stations. At the same time, a large offshore detached breakwater system was constructed along the bay entrance to shield the lagoon network from direct wave impacts. The entire lagoon geometry was designed from the beginning using numerical hydrodynamic modeling. Engineers simulated tidal directions, water exchange velocities, and hydraulic pressure throughout each branch of the canal system to ensure that seawater could travel deep inland while still maintaining enough flow energy. The result is a large-scale self-flushing system that stretches across hundreds of kilometers of coastline, maintaining stable water quality without relying on large, energy-intensive pumping stations. The materials, a closed-loop system. In a desert environment where construction materials are scarce, contractors turned what could have been a massive disposal problem into a closed-loop reuse system. Directly on site, a total of 8 material processing plants were installed along the construction corridor to classify and clean the excavated soil. Fine mud was removed, while sand that met engineering standards was retained and reused as a stable base layer for canal banks and artificial beaches. In many cases, the material had to pass through up to 4 washing cycles before reaching the required level of cleanliness for surface applications. Processing materials on site significantly reduced the volume that needed to be transported away while allowing millions of cubic meters of dredged sand to be reused immediately. The impact, a thriving ecosystem. One of the most remarkable achievements of Sea City is the transformation of the marine ecosystem. What was once a Sabah landscape with almost no aquatic life now supports more than 1,000 species, including around 100 species of fish and shellfish. Seagrass, coral, sea turtles, and even dolphins have begun returning to the inland canal system. Recent reports show that the waterways now contain over 60% of the species marketed in Kuwait. The city is a case study in how coastal development projects can successfully integrate ecological engineering principles to promote thriving artificial marine habitats. The reality, a city coming to life. Today, after more than 2 decades of construction, the project has already created approximately 186 kilometers of new coastline, moving close to its original target of over 200 kilometers. Thousands of waterfront homes have been completed, with around 10,000 residents already living in the city during the early development phases. In June 2026, United Gulf Construction Company, UGCC, announced it had completed all major development works on its $450 million contract at Sea City. The contract included the construction of buildings with a total built-up area of over 610,000 square meters, complete infrastructure including roads and power substations, 930 housing units, 6 mosques, and 5 schools. The work also saw UGCC undertake 10 million cubic meters of bulk earthworks and 400,000 cubic meters of concrete. The Kuwait Ministry of Education has also approved plans to construct 7 new schools in Sea City to meet the growing demand from the rapidly developing residential areas. The future, a new coastal city. More than 3 decades after the first sketches were drawn on paper, Kuwait's Sea City has transformed a lifeless Sabah landscape into over 186 kilometers of new coastline carved directly into the desert. But the most remarkable achievement here is not the luxury waterfront villas or the expanding marina districts. It is the way engineers turn the natural tidal system itself into a giant urban engine, one that continuously refreshes water, stabilizes shorelines, and even helps rebuild marine ecosystems over time. Sea City is more than just another coastal real estate project. It represents a national-scale experiment in how humans can reshape entire coastlines using hydrodynamic engineering. And this raises a bigger question for the future. Will tomorrow's coastal cities still be built on land? Or will they increasingly be engineered directly from the sea itself? If you enjoyed exploring this megaproject, don't forget to like the video and subscribe to Megaconstructs to discover more of the world's most ambitious engineering stories.